Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on February 27, 2026, just 4 days ago. It introduces a massive new resource for training software engineering agents, consisting of over 32,000 executable tasks, spanning 20 languages and more than 3,600 repositories. The paper is titled SWE-rebench v2, Language Agnostic SWE Task Collection at Scale. And as we'll see later, the automated pipeline used to build this collection has some really impressive capabilities for verifying code in diverse environments. And for those interested in the implementation, the authors have shared their code on GitHub. To understand the scale of this effort, Table 1 details the filtering funnel. The process begins with a massive pool of nearly 30 million pull requests. However, requiring existing tests immediately cuts this number down to roughly 8.6 million. The most restrictive step is finding pull requests that are explicitly linked to an issue, which leaves just over 800,000 candidates. After filtering for successful execution in clear problem descriptions, the authors arrive at the final collection of 32,000 high-quality tasks. Moving to the verification stage, Table 2 evaluates how successfully different automated agents can install these diverse repositories. The results compare a basic non-interactive script against interactive agents powered by models like DeepSeek v3.2 and QN3. The non-interactive baseline struggles, managing a success rate of just over 12% on the first attempt. In contrast, the interactive agents perform much better, with the strongest model in the bottom row achieving a pass at 10 score of nearly 63% when given a long context window. Alright, validation isn't just about code. Issue descriptions must also be clear. Table 4 compares different large language models as judges for this filtering task. The top row shows that GPT-OSS120B provides the best balance, achieving the highest F1 score of 0.36. In contrast, Gemini 3 Pro near the bottom hits 92% precision, but its recall collapses to just 5%. This shows why the authors chose the more balanced open model to avoid discarding too many valid tasks. So, having built this filtered dataset, Table 6 presents a diagnostic study of how current frontier models actually perform on it. The authors tested 7 models across 5 languages: Python, JavaScript, Go, Rust, and Scala. Claude Opus 4.5 leads the pack, achieving an overall pass at one rate of 25.2%. Interestingly, performance varies significantly by language. For instance, the top model scores 36% on Python, but drops below 20% on Scala, highlighting the challenge of lower resource languages. Well, having seen how models perform, Figure 1 now breaks down the dataset composition itself. The left chart tracks the issue dates, revealing a clear trend toward recent data. The volume of tasks grows consistently, culminating in a peak of over 7,000 pull requests from 2024, which means the benchmark reflects modern software practices. Switching to the right, the language distribution confirms the project's broad scope. While Python and Go lead with nearly 8,000 tasks each, substantial portions of JavaScript, TypeScript, and Rust ensure the benchmark remains truly multilingual. Alright. While the previous figure covered languages and dates, Figure 2 characterizes the actual content of the tasks. The left panel displays the mix of issue types, where core features dominate at over 40%, followed by minor bugs. This ensures agents are tested on creation, not just repair. On the right, the difficulty distribution, proxied by patch size, shows that most tasks are of medium complexity, with fewer falling into the easy or hard extremes. Wrapping up, 2 takeaways stand out. This framework overcomes the bottleneck of manual environment setup, and it delivers a massive, multilingual dataset for training robust agents. By enabling reproducible execution across 20 languages, it paves the way for more capable and generalized software engineering models. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.